Module 8 Mechanisms of GUV inactivation. In this section, we explore how GUV inactivates bacteria and viruses, photons damage cells, susceptibility of microorganisms and viruses to GUV, and examples of well-studied bacteria and viruses. GUV inactivates bacteria and viruses differently. Bacterial cells, the target molecule for the UVC photons is the DNA molecule in the nucleus of the bacterial cell. For viruses, they do not have a cell, so RNA is the target of the UVC photons. Germicidal ultraviolet inactivates microorganisms by damaging their structure. So GUV inactivates bacteria and viruses by damaging the structure of their nucleic acids and proteins at the molecular level. UVC photons are absorbed by these structures and then damage the DNA or RNA in various ways. The more of the UVC photons a lamp can generate, the higher the intensity and the greater the inactivation of the bacteria or viruses. The higher the lamp intensity, the faster the inactivation. So this image shows an unharmed DNA-RNA strand. So all of the nucleic acids are still intact. Incoming UVC photons get absorbed, destroying the adenine-thymine bonds. What happens then is what we call a dimer formation, specifically thymine-thymine dimers form. Now, these dimers create an error in the DNA or RNA, depending on which structure is getting hit. This then leads to microorganisms and viruses no longer being able to reproduce in their pathogenetic state. The cell then becomes sterile. What is noteworthy is that the excimer lamps, the krypton chloride lamps generating 222 nanometers, specifically cause protein damage. Microorganisms and viruses have different structures, so they also then have different susceptibility to germicidal ultraviolet. What is shown here is that fungal spores are the least susceptible, meaning it takes a lot of germicidal ultraviolet to inactivate fungal spores. On the other hand, looking on the right, viruses are much more susceptible to germicidal ultraviolet, and so it's much easier to inactivate viruses than fungal spores. In between, we see bacterial spores, mycobacteria, vegetative bacteria, and so these are ordered, these organisms, from least susceptible to most susceptible. So again, it is not one size fits all, but depending on the microorganism or virus, the level or amount of germicidal ultraviolet delivered really then determines the speed of inactivation of the respective microorganism or virus. Here we see some examples of well-studied bacteria and viruses. There's much research on these disease-causing bacteria and viruses. For example, SARS-CoV-2, measles, influenza virus, chickenpox virus, and Mycobacterium tuberculosis, in short TB, are very well studied and understood, and the effect of germicidal ultraviolet and the amount needed to inactivate them is fairly well understood. So in summary, let's review the key points. Bacterial cells, they have a different makeup as compared to viruses. So here in bacterial cells, the target molecule for the UVC photons is the DNA molecule in the nucleus of the bacterial cell. Viruses do not have a cell, so RNA is the UVC photon target. Now, GUV inactivates bacteria and viruses by damaging their structure of either the nucleic acids or the proteins at the molecular level. The more UVC photons a GUV lamp generates, the greater the inactivation of the bacteria or virus, and the cell will die off, meaning it will be inactivated. Viruses generally need fewer UVC photons as compared to bacteria to be inactivated.